So hey everyone, welcome to another lecture in the calculus series by the MLM. So in today's lecture, we will be discussing one more type of classification, and then we will be solving few of the illustrations, which are some practice problems and PYQ. So let's get started. So before jumping on the problems, I need to discuss one more classification regarding the function. So let us assume two sets, set A with 4 elements 1, 2, 3, 4, and set B with again 4 elements A, B, C and D. So first definition is into function. So you might have heard this term into function, onto function, injective function, surjective function, bijective function. So we will be clarifying all these definitions in terms of functions. Starting with what exactly is an into function. So let us assume a function is defined as from A to B. And one more thing, before jumping into function, if this definition is given to you something like this, there is a function from A to B. So a common misconception is that whenever you see this sort of relationship, you straight away jump and mark this B as the range of function, which is incorrect. This B is not the range of this function. In fact, it is known as codomain. It is known as codomain and not the range. So what exactly a codomain is? So if you see the definition of codomain, the set of values that the function is allowed to output, the set of values that the function is allowed to output is known as the codomain of that function. Or you can also say declared in the function's definition. So this is the form of a function definition. It is how a function is defined to you or given to you. F is from A to B, where B is the codomain. But then what is the range? The range is the set of values that the function actually outputs. The set of values the function actually outputs that might be the subset of B. The subset of B, which is the range. So for instance, just for reference, if a function f is given to you from R to R, a function is given to you from all real numbers to all real numbers, and the function is defined as fx is equal to 1 by x. Fx is equal to 1 by x. So here if you see the definition, if f is defined from R to R, so this R will be the codomain. And seeing the function's definition, we can definitely say that x is equal to 0 is not defined, right? So therefore the range will be R minus 0. All real numbers except 0 will be part of the range. So range is not equal to codomain. Why? Because codomain represents all the values that are allowed in the output set. So all real numbers are allowed. But for x is equal to, but for y is equal to 0, there is no corresponding mapping for x, right? So if you see the definition, only the actual outputs, only the set of actual outputs are the part of the range. So this is the very basic difference between range and codomain. Alright, so now let's come back to the definition of onto functions. So if a function is defined from A to B, where B is the codomain, is called an into function if at least one element in B, if at least one element in B, which is the codomain, is not an image of any element in A. If at least one element in B do not have an image, a corresponding image in A. So let's assume these are two sets A and B. A is having a 4 elements 1, 2, 3, 4. One, 2, 3 and 4. And again B has 4 elements. A, B, C, D. So the definition of into function says if the function is mapping in such a way that at least one element in B, at least one element in B do not have a corresponding image in A. So let's have this as the mapping of this will be a into function. Why? Because we have an extra element D which do not have a corresponding X. We have a Y in B which do not have a corresponding X in A. So this is an into function. Alright. So now let's see what an onto function means. So similarly, you have a function from A to B. It's called an onto, and onto functions are also called as surjective functions. It is equivalent to onto function. If every element in B, which is the second set, is the image of at least one element in A. If every element in B, if you have a mapping from A to B, so every element in B should have a corresponding mapping in A. If this holds, then the function is onto. Or in another terms, you can also say that if the function is not into, then it's an onto. So both into and onto are mutually exclusive set. Either a function will be into or a function will be onto. So again, let's draw the mapping. This is A and this is B. Again, 4 elements. So if you have this mapping, 1 is mapped with A, 2 is mapped with B, 3 is mapped with C, and 4 is mapped with D, then there is no element left in set B that do not have a corresponding X in set A. So this is an onto function. Alright. So by seeing this mapping, we can also conclude that if the range is equal to codomain, in this case, the range is B, entire B, and codomain is also B. So range and codomain are equal. So whenever range is equal to codomain, the function is always onto. Whenever the range is equal to the codomain, the function is always onto. But in this case, codomain is B, B is codomain, but B minus small d is the range. So here codomain is not equal to the range. Range in fact is a subset of codomain. So then the function is into, else function is into. So you have to remember it. Alright. Now let's see 2 more definitions regarding these classifications of function. So you might have heard this term injective and bijective. We already discussed what a surjective function means. So if a function is onto, then it is also known as a surjective function. Then comes injective function. So if a function is having a one-to-one mapping, every one element of X is mapped with a single element in the second set, which is Y. The mapping is one-to-one, then it is an injective function. And if a function is both surjective and injective, then it is also known as bijective. And it is both one-to-one and onto. So if you encounter these terms, onto function, into function, codomain, range, injective function, surjective functions, bijective function, it should be very clear to answer problems involving these terminologies. Alright, so now let's see a few of the illustrations. So if a function f is defined from R to R, and the definition is fx is equal to 2x minus 1 another function g is defined from r minus 1 to r as x minus 1 by 2 divided by x minus 1. Then we need to comment about the composition f of g, whether it is 1 to 1 or not, or whether it is on to or not. So first define f of g. F of gx will be equal to f of g of x, okay, and it is already given to us that f is defined from r to r, where this r is the codomain of f. Codomain of f. So f of g will be 2 times x. So I will be replacing x with g of x, which is x minus 1 by 2 divided by x minus 1 minus 1. This will be f of g. So if we simplify, this comes as 2x minus 1 minus x plus 1 divided by x minus 1. I have taken LCM. This one will get cancelled, this x will also get cancelled, and it will be x divided by x minus 1. So this is f of g of x. So now the composition given to us, we need to comment about f of g. So if you see it closely, it is equivalent as f of gx. This is what it means, and it is defined as f is defined from r to r, where this r is the codomain of this function f. So if no matter what is placed inside this f, if I am talking about the composite function, the composition f of g, the codomain of f of g will be equal to the codomain of f of g will be equal to the codomain of f. Why? Because the outer function is f of something, f of anything from r to r. So the codomain of f of g will be equal to the codomain of f. So this you need to keep in mind. So now if we closely see this function x divided by x minus 1, what will be the domain? The domain will be all real numbers minus 1. And what about range? So to calculate range, I will be equating it with y. So to calculate range, it will be equivalent as y is equal to x divided by x minus 1, and will form the equation x is equal to some function of y. xy minus y is equal to x, which is x times y minus 1 is equal to y. Therefore, x is equal to y divided by y minus 1, and it can be set as f of x is equal to x divided by x minus 1. So all possible x's of this function will be equal to the range of original f of x, and it is also r minus 1. So if you compare the range with codomain, are they equal? Is the range of this function f of g is equal to the codomain of f of g? The answer is no. Why? Because the codomain is all real numbers. The codomain is all real numbers, but the range is all real numbers minus 1. So therefore, there won't be any two x which are mapped to same y. Therefore, it will be a one-to-one function, but not onto. Why it's not onto? Because range is not equal to codomain. Range is not equal to codomain. Alright. So can we similarly say whether gx will be an onto function or not? So again same, if you replace it with y and try to form the equation x in terms of f of y, you will find that the range of g of x will be r minus 1. 1 won't be the part of range. but the codomain is defined as R. So g of x is also not an onto function. G of x is into. So this will also be an into function. And same holds for f of g. F of g will also be an into function. Alright. Again, so this is a previous year question, was asked in CS 2015. You need to choose the most appropriate equation for the function drawn as a thick line represented by the white line in this plot. 4 options are given. So this you can anyway easily calculate. So it is somewhat a mixture of a straight line and a mod function. So for if y is greater than 0, in this case if y is greater than 0, in that case x will always be 1. If y is greater than 0, then x will always be 0. And if y is less than 0, then it should always pass with this from this point, which is 2, minus 1. So any equation, any option satisfying these two conditions will be the right answer. So let's see for the first one. We'll place any positive y in the equation. Say let's assume y is 1. Let's put y as 1. So it will give us x is equal to 1 minus modulus of 1, which is 0. So this is satisfying the criteria, which is first. Then we'll check for the second. Whether it is satisfying this point 2, minus 1. When y is minus 1, from this equation, part A, x turns out to be minus 1 minus mod of minus 1, which is minus 1 minus 1, which is minus 2, which is incorrect. So 1 is not right. It is not satisfying the second one. Let's see the second. For B, for option B, it is given as x is equal to minus of y minus mod of y. So when y is 1, x is 1 minus 1, 0. It is right. When y is minus 1, x is minus of minus 1 minus 1. It will be 2. So it is also correct. Answer B is, option B is satisfying both the condition. Same if you can check for C and D, it will invalidate. So the right answer is option B. Again, one more function is given to you, f of x, as x times greatest integer function x divided by x square minus 1. And it is defined from 1, 3 to r. R is again codomain. So whenever you see the greatest integer function, you straight away, one thing should always click in your mind, that this function is not continuous on the integers. So the range is given to as 1, 3. We'll straight away split it. F of x is given as x times GIF of x divided by x square plus 1 for x 1, 2, 3. So therefore f of x we'll split it into 2. First is 1 to 2 and then 2 to 3. So if the first range, if x is from 1 to 2, GIF will be always 1. So it will be x divided by x square plus 1. Or else it will be 2x divided by x square plus 1 for x greater than equal to 2 but less than 3. So this is what f of x is given to us. Then we need to find the range of this function. So range can easily be calculated. You have 1, you have 2. Just put it here and try to find the range of all possible y's if x is greater than 1 but less than 2. And same we will be doing for the second one. So it's a piecewise function. So considering this, f of 1 will be 1 divided by 1 plus 1, 1 by 2. F of 2, for the first part, it will be 2 divided by 4 plus 1, 5. And again, f of 2, for the second piece where x is from 2 to 3, it will be 4 divided by 5. And finally, f of 3, it will be 3 times 2, 6 divided by 9 plus 1, 10, which is 3 by 5. So if we keep the denominator as 10 in all of them, it will be 8 by 10. It will be easy to compare. 4 by 10 and this is 5 by 10. So in the first range, y is from 4 by 10 to 5 by 10. And in the second part, y is from 6 by 10 to 8 by 10. So among these four, finally f of 2 is 4 by 5. So this is right. This is right. In the second part, it is from 3 by 4 to 4 by 5. So A is the right answer. And in the first, it is from 2 by 5 to 1 by 2. From 2 by 5 to 1 by 2. And in the second part, it is from 3 by 4 to 4 by 5. This is 4 by 5. And this is 3 by, it is 3 by 5, not 3 by 4. It should be 3 by 5. Okay. So now let's see one more PYQ. This was asked in CS 2014. So the problem is the roots of ax square plus bx plus c, which is a quadratic equation, are real and positive. And a, b, c are real. Then one more variation in which x is replaced by mod of x is given, and it is asked that will this equation will be having no roots, 2 roots, 3 roots or 4 real roots. So let's analyze based on the given information. Based on the given information for this equation ax square plus bx plus c, it is given that roots are real and positive. Roots are real and positive. This is y, this is x. So if the roots are real, it should cross x-axis at 2 points, and since it is also given that both the roots are positive, so the graph should be like this. It should pass to the positive x-axis at 2 points. Both the roots are real and positive. Okay. So now if f of x is given as ax square plus bx plus c, this equation is f of modulus of x, right? This is what is asked. So if there can be two parts, if x is greater than 0, if x is greater than 0, then well and good, it is equal to f of x. If x is greater than 0, nothing will change. But if x is less than 0, then it will become ax square minus bx plus c. So if you closely see, this equation is equal to f of minus x. If fx is ax square plus bx plus c, f of minus x will be this. Okay. So now the new graph of this equation will be splitted into two parts. First, what the value of y for which x is greater than 0, the value of y for which x is less than 0. So if I draw it with another color, say red, for this portion x greater than 0, this will be the graph. This is correct. But for x less than 0, it will be f of minus x. F of minus x will be the mirror image in y-axis. So it will be like this. It will be like this. So this equation will be having 4 roots, 4 real roots. So the graph marked with red is the graph of f of mod of x. So option D is correct. It will be having 4 real roots. Alright. One more PYQ. It was asked in CS 2015. Given two functions gx as 1 minus x and hx as x divided by x minus 1, then the composition function g of h divided by h of g will be equivalent to which of these options? hx by gx minus 1 by x, gx by hx, or x divided by 1 minus x whole square. So first we'll be computing both and then dividing in order to find the simplified expression of this function. So first, g of h, we have g which is 1 minus x and we have h, x divided by x minus 1. So g of h will be g of hx. So we'll take g 1 minus and replace hx, x by x minus 1. So it will be x minus 1 minus x by x minus 1 minus 1 by x minus 1. Similarly, we can simplify for h of g, which is h of gx, x divided by x minus 1. So it will be 1 minus x divided by 1 minus x minus 1. This 1 and 1 will be cancelled. So it will be x minus 1 by x. Okay. Now the division, g of hx divided by h of gx. It will be minus 1 divided by x minus 1 whole divided by x minus 1 divided by x, which will be equal to minus x divided by x minus 1 whole square. So now we need to compare it with all these options in order to identify which will be the right answer. So straight away D is incorrect. Why? Because they do not have the extra minus that you have over here, minus x. So let's start with the first one, hx by gx. Hx by gx will be x by x minus 1 divided by 1 minus x. So it is x divided by x minus 1 divided by 1 minus x. So if we take minus 1 common, it will be minus times x minus 1 whole square. So it is equal to minus x divided by x minus 1 whole square, which is what g of h divided by h of g is. So A is the right answer. B is incorrect and C is also incorrect. Why? Because C will be x minus 1 whole square divided by x, which is not equal to this. Easy problem. Here is one more. It was asked in ISRO CS 18. Given a function log of sin x, we need to comment about its domain. So it is given as f of x is equal to log of sin x. This is what the function is, and we already know that the graph of a logarithmic function looks like this. So later in the next module, you will be able to easily comment about whether it is an increasing or decreasing function. But for now, since you already know the graphical representation of a log function, it is an increasing function. So in order to find the domain, we need to first ensure that this, whatever present in the inside part of the first log, should always be greater than 0. Otherwise, it is not defined. So therefore log sin x should be greater than 0. Otherwise this log itself will be undefined. So for this to be true, we further simplify this log sin x greater than 0. We will be taking anti-log. So anti-log of log of sin x will be sin x should be greater than e to the power 0. Anti-log, right? Which is e. You can take any base, no matter e. Either you can take e to the power 0 or 10 to the power 0. It won't impact the domain of f of x. So this will give you sin x. Anything a constant to the power 0 will be 1. So what are the values of x which satisfy this equation sin x greater than 1? So the answer is no value of x satisfies this. So domain will be an empty set. So C is the correct answer. Alright. Again, one more problem was asked in GATE CS23 from this module, which is functions. So here in this lecture, I am only taking problems related to module 1. Okay. So after completing module 2 and 3, we will see a few more problems on limits, continuity, differentiability and maximum minimum. So the problem says fx and gx are functions of x and y respectively, where f of x is equal to g of x for all real values of x and y. Fx is always equal to g of x for all real values of x and for all real values of y. It is given to us. Then which of the following options is necessarily true for all x and y? Which option will be necessarily true? So first option is f of x is 0 and g of y is also 0. Is it true? Can be, maybe. It can be a case. Option B, what it says, fx is equal to g of x, which is given to us, is equal to a constant. So option, if you closely see this option B, it is also including option A. So it includes option A. So if you have to choose between which is correct, option A or B, B will be a more appropriate option when it comes to whether f of x is 0 and both g of y is also 0, or both are equal and is equal to a constant. So this is true for all x and for all y. If you take anything for f of x and g of x for which it is not a constant, then you can't say that this equation holds for all x and all y. You can take anything. You can take any x or y. It will not validate the fact that they both are equal for all x and for all y. So they both should be, if they both should be equal, it should be a constant. So B is the most appropriate option among the four. So let's see one more problem. Given f of x as x times 4 minus x, which is a quadratic function from minus infinity to 2 to minus infinity to 4. We need to find what will be the inverse of this function. Given f of x, we need to find the inverse of this function. So let's see, f of x is defined, which is equal to y, is 4 times x minus x square. And we already seen that, we already discussed in the class that whenever a function y is equal to f of x, a function, expression is given y in terms of x. In order to find the inverse, we need to convert it into an expression in which x is equal to some function of y. This is the first step. And then interchange the value of y and x and get the inverse. And here it's a quadratic equation, but the domain and range is given in such a way that it becomes invertible. It becomes a one-to-one function. So therefore, we will simplify it for x to get an expression in terms of y is 0. This is what? it will give us, it's a quadratic equation. So solution of a quadratic equation will be x is equal to minus b, which is minus times minus 4 plus minus b square minus 4ac divided by 2a. Okay, so which is equal to 2 plus minus 4 minus y by, that's it. So either it can be 2 plus 4 minus y or it can be 2 minus 4 minus y. So option C and option D are itself eliminated. Why? Because it is having a minus 2. So either it will be option A or option B. So here we need to eliminate which is the incorrect one. So but first let us replace y with x. So either it will be 2 plus 4 minus x or it will be 2 minus 4 minus x. So for this we have already we have given the range and domain of the function. So whenever there is a function f, it is a generic definition that I am giving. If f is defined and a point a comma b is given on that function, so a is mapped with b. So therefore for the inverse, the same point will be replaced. The inverse will always have a mapping from b to a. This is the generic definition of inverse, right? If a point a comma b is given in a function, then b comma a will be in that inverse. So we need to find a mapping a to b in such a way that a corresponding b to a mapping either should present on this or this. Whichever holds true will be the correct mapping. Then the second one will be eliminated. So here if we place x as 3, if x is 3, then f of x, it will be 3 times 4 minus 1, which is 3. It will be 3. If x is 3, then y is also 3. You can take one more. If x is say 1, then f of x will be 1 times 4 minus 1, 3. So let's assume we have point 3 comma 3 and we have point 1 comma 3. Then both 3 comma 3 and 3 comma 1 should be present over here. Okay, so it is a mapping from 1 to 3. Then there should be a mapping from 3 to 1. Let's put 3 over here. If x is 3, here if x is 3, then f inverse will be 2 plus 4 minus 3, which is 1. So it is 3. And if x is 3, in the second case, if x is 3, then f inverse will be 2 minus, which is 1. So out of these two, this is right or this is right? If x is 3, then it should map with 1. Why? Because in the original function, in this function, when you put x as 1, it will give you f of 1 as 3. So in the inverse, if you put x as 3, it should always give you 1, not 3. So this becomes incorrect and this is the right answer. 2 minus square root of 4 minus x. This becomes invalid. Why? Because it is not giving us the correct mapping. Alright, so that's all in this practice session. So this practice session is dedicatedly for module 1, which involves problems related to functions. See you in the next class.